Hey everyone, welcome back. So if you stuck around for my last two videos, we went over, the first video was an introduction to gRPC protocol buffers and setting up our server. Second video was us making our unary call, our client streaming call, and our server streaming call. So we went through three different calls in our second video, and in this video we're going to go through finally the last call, which is bidirectional streaming, and we're going to simulate this this sort of example through a chat app. So I hope you enjoy, and I will see you around. So welcome back. We're going to go over the last one, which is bidirectional streaming through gRPC with clients and servers. You already know everything. I'm not going to go over what we did in the last videos. If you really want to go watch it, I'm going to link some the last two videos up somewhere in the description. So click them and definitely come back and watch this video. So let's get started because we got a lot, generally a lot of code to cover compared to the other calls that we've done. So let me comment this out and let's create our chat service. So let's go up over here and let's do RPC chat. And this time, what we're going to do is we are going to, we need a way for users to send their message and their name and just get back a response with the other people's name and their message. So that's what we need to do. I think that's the bare minimum we need to cover. So chat request and chat response. So it's going to be, the server is going to take a stream of chat request and it returns a stream of chat response. So if you notice now that there's stream both in the function arguments and both in the return arguments. So let's create chat request and chat respond here at the bottom. So message, it's going to be chat request. And all it's going to be is a message, a string with the variable message. And that's all we need. The name, I'll show you how to inject the name into this chat request. It's not that important. What's important is if you go to a message, we want to send the name back out in the chat response over here. So this will contain a string of the username and the string of their message, right? So now, the fun part, yarn proto gen, and let's compile this. Seems like we got errors again. This thing loves spitting out errors, you know. Let's see what we did wrong before we actually see. Oh, I see. Okay, so this, yep, proto gen, chat. Yep, that worked. Okay, so cool. So now we got our chat request and our chat response. Let's close this and let's create now the handlers for the server. So for the server over here, look at that beautiful IntelliSense. Oof, right? It's going to take a call and that's about it. It's just going to take a call over here. And I'm wondering if I should comment all this code out to not confuse anyone watching this video. I think it's fine. I think everyone knows their stuff over here. So what I'm going to do is I'm just going to focus on this chat service, right? It just has a call object over here. So what's going to happen is every new client that comes in and initializes their connection with the server to chat, it's gonna initialize a new call object. So it's gonna pass a call object for every user, and every time a user sends a new request, it's gonna be the same call object. So what we're gonna do is we're going to associate the user's name that they send in, which I'll show you how to do it. Remember, we're going to associate it with their call object, and then through their call object we're going to send data back to the user. We'll say that user 4 and user 5 send heys and highs. It's going to go to our call object and send it to them. Okay, enough of that. Let's do it in the code. So in our chat, what we're going to do is first we need to create a map of all users. So I'll go at the top over here and I'm going to say const user. I'm just going to call object by username, and it's going to be a new map of it's going to be, I'm going to initialize the map like that, and it's going to be a string, and it's going to be a call object. Now, because we're in the beauty of TypeScript, we can sort of type infer the value to this, which will be the call object. It's very hard to type. There's no primitive types that we can use to define this, but luckily for gRPC and TypeScript we can. So gRPC dot server duplex stream, right? It's a bidirectional stream, and inside there it's going to be a chat request and a chat response, right? Chat request, chat response. I feel like I'm missing something. Oh yeah, another arrow bracket. Okay, cool. So chat request and chat response. Cool. So that auto imported these at the top over here, so we're all good when it comes to that. So now we got this call by call object by username. So now we can go down over here, and now let's get the user's name. So const username is equal to call dot metadata. So metadata is where we're going to store the user's name. So call dot metadata dot get, and it's going to be, we're going to expect something in the username. And the way that headers actually work, like if you know in HTTP, all headers are arrays. They're all arrays. That's just the way it is. It's very flexible that way. So we expect something in the first index, and since it's very hard to type infer this, so we're just going to say it's a string and it's a primitive type, so it doesn't matter too much. So it's going to be a username. So now simply what we're going to do is also get the message. So const message is equal to call dot it's going to be I see. So call, obviously because it's bidirectional streaming, we have to listen to the data events. So data, and it's going to be a call, it's going to take a callback function where it has the request, right? It's going to have the request in there, and we can now do request request dot, why isn't this working? Oh, it's inferred as any again. That's annoying. It's pretty much as message. And you know what? This might actually fix itself if I do this. Might, I'm not sure. Usually when you reload the browser, the type checking comes back. Sometimes it doesn't, sometimes it does. Can't win it all, Okay, so we got our request and we got our message, and now what we're gonna do is we are going to so if the user's name is not in the map, then we want to send this new message out to different users. So how we're going to do that is for let user and user, or we're just going to call this users call, right? Of users. It's going to be iterating through that. And what we're going to do, is this name users at the top? No, it's called call object by username. Okay, call object by username. And over here, we're just going to be like, if username, it does not equal to user, then we essentially just want to broadcast this message. So where if it's not the user, then we want to send this message out to the person, because this is now, it's me sending when you send a chat request, it gets broadcasted to everyone but you. So that's what we're doing here. So user call dot write, and it's going to have the username, username, and then it's going to have the message of the message Cool. So that's how we send it out to everyone. And then at the end over here, we actually want to set this user's call object. If this is a new user, we want to store this call object. We don't want to lose it. So the way we do that is if call object by username dot get username, and if that does equal undefined, right? If we don't have the call object currently, then we want to store it. So call object dot set, the key will be the username, and the value will be the call object. It's that easy. All right, so now we defined our data, our on data callback. What we need to do now is to define the end. Like if the client cancels the communication, we want to also handle that. So call on end, call dot on end. I wonder if this passes anything. Let's see, on end. No, it's just an empty listener. So what we have to do then is we have to get the username from the metadata. So we got to get the username from the metadata, and then we have to get the call object. So const do we need to get that? Because the call is right over here. Yeah, so we can initialize the call over here, but what we actually need to do is delete the user who is disconnecting. We got to delete their call object from the map. We don't want to store it. That's going to cause a memory leak. So let's just delete it. So dot delete by username, and then all we're going to do is call dot write, right? We're going to write something over here. It's going to be a message that says see you later, and it's going to have the user's name, and I forget, is this the response or the request? Because I need to set the, okay, I can set the username, so I can just say this is the server, and that is essentially it. And then at the end over at the very end, just to do a cleanup as well, if the client's ending the communication, I'll make the server end it too. So that's essentially it for our server side. That's all we need to do for our server side code. Just to make sure things are working, I'll just do a yarn start just to see if our server starts up, and it does. Kabba bing bada boom. You know, that was not even the right phrase. Okay, so now let's go back to our client and let's code this out. So now as the client, I'm going to do client.chat. Okay, so what I need to do is I need to pass in the metadata. So the metadata is what I was talking about, right? Because the client's request can only contain the message. So we need to attach the metadata. And the way we do that is there's this, we can initialize metadata. So the way we do that is const metadata is equal to new gRPC dot metadata. See that? Pretty cool. So now we can say metadata dot set, and this is the username, and the username is, let's just put my name right now, Floyd. I like t.code. I like to refer to myself as t.code. So we're setting now the metadata in the chat, and what's going to happen is we're going to get our call object from here. So whenever it's a stream, whenever the person who can do the stream has the call object, so he can send data. So what's going to happen now is I can write stuff. So the first thing I'm going to do is I'm going to write something called register. So write register, sorry, message register over here. Okay, so now I want the chat to occur through the command line, the terminal. So what I'm going to do is I need to import something. I need to import readline from readline. This is something that's built into Node, so it's completely, you don't have to download a third-party package to make this work, so it's perfectly fine. So what I'm going to do is, before doing the metadata, I'm going to initialize a new readline. So equals readline dot create interface, and the interface's input is going to be process.stdin, and the output is going to be process.stdout. Simple as that. Okay, so now this is what we're going to use to write messages and write out messages. So what happens is now there's a callback function that readline takes. So readline.onLine, and it's going to take a function which passes the line. It's going to pass a line, and in here, it's just going to be reading the lines that I feed in. So one thing I want to make it listen for is quit, because when I want to leave the chat, I want to leave the chat. So line, if the line's equal to quit, then I want to call.end, and I just want to return, right? That's all I want to do. Otherwise, I can just make this an else then, and then I can remove this end. Yeah, I do Golang too much and just try to quit early is one of the key things. Okay, so call.write, and I want to write a message, and the message will be pretty much the line, plain and simple. Okay, so now another thing is that I want to see other users' text. So the way I'm going to do that, I'm going to display that sort of fancy on my terminal. Now I'm not going to use chalk or something. I want to keep this as minimum third parties as possible. You can do that in your spare time if you want. So it's going to take in a callback function with a chunk, and the chunk is going to be any as usual. Oof, so annoying. Doesn't matter. Console.log. How do I want to format this? Chunk dot username, and then their chat message is going to be chunk dot message. Let me save that. Let me see whether I named these right. So message and username. Okay, cool. Very simple, plain and simple over here. So now let's go through this whole process. I start this. Right now I'm hard coding the name. So what I want to do is when I start my client, I also want to pass in an additional argument, which will be my name. So how am I going to do that? Node also has a neat little thing called process.argv, and we are going to take in the second argument over here. And what we're going to do, just as a failsafe, because I really want a username to exist. So if no username, then I just want to console error no username can't join chat, and then I'm just gonna return over here. Sorry, I'm just gonna exit the process. So process.exit. Cool. So that's all we need for that. And now we can pass in this username instead of some hard-coded value over here. So someone starts off our script and they put in their username and they register over here in the register. And then every time they get data, they'll output it over here. And then finally they can write their stuff over here. Pretty cool stuff. We can listen to a call.end as well. but I don't think that matters too much in this case, especially for our little service over here. What we're going to do is we're going to console logs are good. It helps to see where you're going. So what I'm going to do is console log request, just to see if we're on the right track. And end is super important too. So console log is username is ending their chat session. Okay, so let's run this. Yarn start. Server, do not fail me now. And you failed me, god damn it! Oh, because I have it all over here. Never mind, I'm stupid. So, yarn start over here. Okay, server is started. Boom, boom. Yarn client t dot code. Let's see what happens. Ooh, seems like I'm in. Let's see what happens over here. Ooh, message receive register. Ooh, this is cool. This is cool. Okay, so now let's make another person join the chat and see what happens. So yarn client Joseph. Should have picked an easy name to spell. All right, so Joseph is joining the chat. Did I paste that? Yeah, I did paste that. Joseph registered over here. So I am receiving that message that Joseph has registered. Let's go to our server, and we got two register messages. So now let's a moment of truth. Hey there, Joseph. How are you? Enter that. Let's go over here. T.code. Hey there, Joseph. How are you? Okay, so this is pretty cool. Let me put it side by side. Did they stop doing this? This is annoying. I want to see it side by side. Who doesn't want to see it side by side? Split. Sorry, let me figure this out, guys. Okay, so I see. So that's how you do it. So let me just cancel all of these. Actually, the best way to cancel this is just to cancel the server. So where's the server? Client server over here. Okay, cancel that. So now both the clients are canceled. And now let me just close all of that. Delete this. Kill terminal. I split this. Clear. And let's split one more of these bad boys. Okay, so now let's see how all this ties in. So yarn start. It's going to start our server. And then server started. Okay, so yarn client t.code. T.code has registered. Cool. And now we can go over here and do yarn client Joseph. Joseph is trying to join, and it says Joseph has registered. Hey, it's me, Joseph. Hey, Joseph. Joseph? Okay, Joseph. What's up? T.code sent that message. Nothing much. And then, okay, dude, I love you and all, but I need to go. See you later. And now I can do quit. And it says server, see you later. So that's pretty darn cool. Well, what we can do also as a neat little functionality is right before the client ends, I can send a broadcast message to all users saying that Joseph has left the chat. So let's actually do that because I'm super curious. So what I'm going to do is I'm an efficient programmer, so I'm just gonna copy all of this. I deleted so Joseph left, I deleted Joseph's call. So all I will have in this map is just everyone but Joseph, so I don't need to do this extra check. And I can just say username Joseph, and the message is has left the chat, and that would be it. So that would be the user call, and I do not need the username. And then yeah, so that's all I need. Yeah, that is it really. Let me just comment this out because this gets kind of boring. Actually no, I can just string interpolate this. I can do username and then request dot message over here. Okay, so let's restart this server. Let's clear this. And let's do this once more. And this time we're gonna make Joseph join first. So yarn client. Let's name this John Doe because John Doe has joined. So yarn client t dot code. T dot code has registered. Hey, what's up, John? Nothing much. Codemeister. Man, I'm such a boomer. And now I'm like, okay, so now I want to quit. So I'm going to quit from t.code. And it says now over here in John Doe's chat that t.code has left the chat. And surprisingly, that is also the part of the video that we have reached. We have covered, guys, 4 different types of RPC calls using Node and TypeScript. So this is a bunch of content that I've put out around gRPC, and you can go off and start building your own applications using client and server-side stuff. How I'm going to extend this further is I'm going to take this server-side code to the browser, and I might attach it to a database or some sort just to show how gRPC can kind of be used on browsers. I do know I said that it doesn't really work on browsers because number 1, it requires HTTP2. Not all browsers support that, and number 2 is no browser supports protocol buffers. Like that's a lot of binary conversion back and forth, and protocol buffers also does need some low-level construction of the HTTP stack. So browsers don't really allow that, so there's no direct way to do protocol buffers to protocol buffers client to server communication. Maybe there's something out now that I don't know about, but I do know a way that I can make that possible. So I'm going to go over that in the next video. Also, I'm going to compare protocol buffers with Node and TypeScript with something like Fastify, and we're going to put those two side by side and see which one and how well they how well they compete with each other. So I hope everyone enjoyed this video as much as I did. I'm going to leave the code down in the description if you want to use it or you want to contribute to it, whatever it is. And there's also a couple links down where you can find me on other social media platforms and show some support in various ways. So I hope everyone enjoyed this video, and I hope to see you in the next one. Peace.